Bismillahirrahmanirrahim. Hello everyone, welcome to Math School. Uh, Today we are going to discuss about arithmetic progression, and this is a recorded lecture, so uh, listen to my lecture very carefully so that you can understand it properly. And if you have any kind of question later on, you can ask me and I will come on live. I will tell you when I'll be available. So today I'm just going to discuss some slides on arithmetic progression. I hope it will help you to understand um, something about um, arithmetic progression. Okay, and for this purpose, I'm going to use Zoom, and for the better understanding, I'm going to share my screen. Actually, I'm not very much used to this kind of lecture, so I'm trying my level best to give you some kind of, good delivery. So let's see what is in my slides. So for that purpose, I'm going to share my screen, and yes, here is the screen. So I'm just going to open it first. All right. So now I'm going to open the slides. All right. So here is the first slide. You see, this is the heading. Heading is basically arithmetic progression, and in bracket you see it's AP. Actually, this is the shortest form. In short form, we just call arithmetic progression as AP. So AP means arithmetic progression. Sometimes we can say that arithmetic progression means arithmetic series. Anyway, so it is a sequence basically where the numbers are consecutively coming with a clear and constant, fixed difference. That means when you are just going through the sequence or series, you'll see an interesting characteristic or property in this sequence. And what is that? And you see, I'm just using an example here. I'm just example 1. See, the numbers are like 3, 7, 11, 15, 19, 23, and so on. So here you see a fixed difference, constant difference, 4 between the numbers. Okay. All right. So this sequence is an AP. Why? Because AP, the property of AP is that when the consecutive numbers have a constant difference, and here you see that the constant difference between the numbers are like 7 and 3, it's 4, 11 and 7, it's 4 again, 15 and 11, it's 4, and so on. So you see the nature here. There is a constant difference, and so this is an AP. And this constant difference, since it is a common difference, so we can use the term common difference for this kind of difference. Mathematically, we can determine this by just using a rule, that is common difference. Basically, it is denoted by T, and the rule is post term minus, subtraction, the preceding term. That means if you think about the example that I used before, here post term, 7 is a post term, 3 is a preceding term. Similarly, 11 is a post term and 7 is a preceding term. 15 is a post term, 11 is a preceding term. That means always you have to find the difference just subtracting the preceding term from the post term. Here 7 minus 3 or 11 minus 7 or 15 minus 11, always you will find the difference, common difference. Here we get 4. So this is an AP with a difference 4. Okay, we can see another example here. The example 2, the sequence is like the numbers are coming as 30, 25, 20, 15, 10, 5, 0, negative 5, negative 10, and so on. And here the common difference is negative 5. So common difference, negative 5, it is coming as negative. That means by using the rule, if you find the common difference here, post term minus the preceding term again, D here 25 minus 30, or 20 minus 25, or 15 minus 20, or 10 minus 15. So our common difference is coming is as here by using the same rule, that is negative 5. Okay. Here is a phone call actually. I'm sorry for the interruption. Hello? Hello? All right, so sorry. So you see that example, the common difference in example 1 was positive one, positive common difference we found, which was 4. Actually, why it was positive? Because the term was in ascending order, means increasing terms. And the common difference is negative when an AP is in descending order, means decreasing, that we see in example 2. Okay, so now some important notations we need to know. There is we use this kind of notation very often, like T1. T1 means first term, T2, T2 means second term, T3 means third term. In general, Tn means the nth term. So this kind of notation we will use for our convenience. Okay, so here is a very important formula in arithmetic progression, that is Tn equals to a plus n minus 1 into t. As I told you before, the Tn, this is a notation to denote the nth term. So that means you can find the nth term in a arithmetic sequence by using this formula. Here A stands for first term, n means the position of the term that we are trying to find out, and the position, say 10th term, 15th term, whatever the position you just decide to find. N stands for that. D means the common difference that already you have used. Okay, so Tn means the nth term. In this example, again 1, you see the sequence is like 3, 7, 11, 15, 19, 23, and so on. So if I want to know a certain term, say for example 10th term, by using the formula that we just discussed, we can find it out, like Tn, as you know, that equals to n plus n minus a plus n minus 1 into d. Here a first term is 3, d common difference is 7 minus 3, which is 4, and n is 10. That is the position of the term we are looking for. So by using this formula, just putting these values accordingly, we can find the 10th term is 39. So 10th term means here in this sequence, we just found by using the formula 39. So here it is very much clear to us that we can find find any term from a certain sequence, especially talking about arithmetic sequence, by using this formula. Okay. Now we come here with another formula. That is, you see Sn equals to n by 2 times 2a plus n minus 1 into d. Close. Here A again stands for first term of the AP, N means the number of terms that we want to add up, D means the common difference, and Sn means the sum of the first n terms. Actually, what is this formula for? Actually, in an arithmetic progression, when you see that you are having some numbers in the series and you want to get the totality, summation of a certain number of terms, then you can use this formula. This is the formula that you can use to find out the summation in an arithmetic progression. Say in example 1, again, uh, we see the terms. And now if you want to get the sum of 10 terms, first 10 terms, of course, actually that is the formula which actually give you the summation of n terms, obviously, but starting from the first term. Okay, so we can say this is the formula. Sn means the sum of first n terms. Okay, so now in this example, I am looking for the summation of 10 terms, first 10 terms of this series. That means here, if we want to use this formula, then A, D, N all are actually just can be found here as first term 3, D, 4 again, and N number of terms we are going to add up. So now putting into that formula, now we can get the sum, which is 210. That means 3 plus 7 plus 11 plus 15. Actually, 10 term is 39, so up to 39, if we add all the numbers in this sequence, that would be 210. So this is the formula that can help us to find the sum of a certain number of terms in an arithmetic progression. Okay, so now, two important things. Why the formula just we used to find a certain term, Tn equals to a plus n minus 1 into d. Actually, this is very interesting. This is, I told you that it is a sequence. So sequence has a certain pattern. So if you just see the pattern here, we can find out why this formula of nth term is like this. Okay, let us consider the arithmetic series to be like this: a, then a plus d, a plus 2d, a plus 3d, then again a plus 4d, and so on. Actually, here d is the common difference, so we can add d successively to get the successive terms. Like first term is a here, second term a plus d, third term a plus 2d, then a plus 3d, a plus 4d. That means adding up d again and again with the preceding term, we can find the successive terms. So if we just now see the pattern, what is happening here, then we can see the Tn, T1, the first term is A. Okay, if we think that A plus, since there is nothing with A, so we can consider, okay, 0 times D. And then again, we can say that A plus, for 0, we can write 1 minus 1 into D. Just, this is we are doing just to see the pattern, what is happening actually with the different successive terms. T2, again, it is A plus D. So we can design it like this: A plus 2 minus 1 into D. T3, also we can design it as A plus 3 minus 1 into D, that you can see here. And T4, A plus 4 minus 1 into D. So the interesting thing is here 1, 2, 3, 4. That is first term, second term, third term, fourth term. And here A, these are constant part in the pattern. Here -1, -1, -1, -1 is a constant part. D, 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 D also constant part. But the number where the suffix are like 1, 2, 3, 4, here with the coefficient part of D, we see the same change is happening 1, 2, 3, 4. That means this is the only thing which is actually complying with the change with the suffix of the term. So other parts are constant. So that's why, according to the rule of sequence we can write that, okay, if it goes like this, 1, 2, 3, 4, and then again, so at a certain time it should be some, say, n. So here constant parts are remaining a, then 1, -1, d, but since it is n here, so it is n here. Because it was a 4 here, it was a 4, 3, 3, 2, 2, 1, 1. But other things are constant, so we keep the constant here. We are keeping it here, and change was like with this suffix n, here it's n. So we see that according to the rule of sequence, the nth term is here a plus n minus 1 into d. So this is one kind of proof why the nth term is a Tn is equal to a plus n minus 1 into d. All right. So now let us see. Um, there was another formula that we have used. The sum of first n terms was Sn equals to n by 2 plus 2 into 2a plus n minus 1 into d. Why it is like this? Let's see. As you know that example 1, we got the sum of first 10 terms just using the formula was 210, right? So now let us use a trick here, okay, to find out the sum in other way. We may write it as S10 as 3 plus 7 plus 11, and thus, and if it goes like this, then 31, 35, 39. Actually, I'm not mentioning all the 10 numbers here, but I'm just mentioning here first 3 terms and last 3 terms. Just I'm writing here like that. Okay, so we can write this actually series in reverse order, like S10 again. I'm just starting with the last term, then the second last, then third last, and then again the first 3 terms coming up just in reverse order like this, you see. So now if you add them up, these two equations, if we add them up, then S10 S10, if we add them up, we get 2 times S10 because there's simple algebraic rule. Then 3 plus 39, 42, 7 plus 35, 42, 11 plus 31 is also 42, and so on. Every time we are getting 42. It's an interesting thing. That is 42 is repeating uh, uh, many times, especially since there are 10 terms, so 10 times it is repeating. So this is a simple thing. 42 is coming 10 times, so we can write the sum as 42 times 10. But this is the sum, which is 420 here. Actually, this is the sum of 2 times S10. This is the sum of that. But we are looking for S10 only. So S10 would be obviously a simple algebra. So 210. So you see, this is a simple trick. If you write down the sequence um, from first term to the last term, then again last term to the first term, and if you add them up, you will get the repetition of a certain sum, and then thus you can find the sum of the whole series. So this is simple trick. Actually, this formula was derived using this kind of trick. So I'm giving you a homework here. Just use the series, that is a plus d, a plus 2d, a plus 3d, a plus 4d, and if you use n term, the last term would be a plus n minus 1 into t. So now if you write as Sn as a summation of these terms, then again Sn in reverse order, try it. Okay, I hope you will be able to solve it out. Just try it. Okay, it's a fun. It will be really fun for you. But I will discuss it in some other lecture. I'll just show you, but you try it first. Okay. All right. I hope you understood in short, very short though. But I just tried to just discuss my slides. I will upload this slide again in the Google class. You can go through it, and you just and first go through it, and then I have given a worksheet also here. You see a worksheet, so you can try this math. The solution is also there at the end. Okay, so you can match your answers. Then I will come on live. If you have any kind of questions, I'll just answer it. I'll discuss it. So till then, bye. Okay, best of luck. Thank you.